because what we're doing next week is super, super important. It is the most important thing we've done all year. What are we doing next week, Carrie-Ann?
Are you getting a haircut again?
No. What are we doing next week? You know what I'm doing next week, Dada, don't you? No. You don't know what I'm doing next? You are a terrible Disney nerd.
Wow.
Mike, do you know what I'm doing next week?
D23?
There you go. D23. We're going to a Disney convention. That's right. I'm that kind of nerd. All right.
We have to do an
right
open.
on.
Let's crank an open out. Let's get Dimitri back because I don't want to waste his entire Saturday.
We don't like
Before
talking
you get rid of
Mike,
me, let's do a quick intro to the show.
Yeah, something you, Mike.
Yeah, something.
So
I'll go satellite launch. You can say crew. Oh no, wait. I'll say space selfie. Oh man, but that's depressing.
It's really depressing.
I'll say space selfie. You say satellite launch, and Mike, why don't you do?
Why a rocket failed.
Yeah.
That works. All right. Ready?
Oh, Mikey, I'm sorry. You call the depressing.
Big
girl.
bada boom. All right.
No, don't say that. Good gods.
All right. Here we go. This is take one. Coming up, space selfie.
Satellite launch.
And why a rocket failed.
Then we're going to be talking to Dimitri, the CEO and CTO of Escape Dynamics. Something. Let's try this again.
So glad that was your fault this time.
Coming up, space selfies.
Satellite launches.
And why a rocket failed.
And then in our main topic, we're going to be talking about a next generation propulsion idea to get a single stage to orbit spacecraft to space with very little fuel. Stay tuned. Tomorrow begins right now. I did not like that. We're going to do that again.
Okay.
3, I was just like, blah. Okay. All right. Coming up, space selfie.
Satellite launches.
And why a rocket failed.
Plus, we're going to be talking about next generation propulsion as our main topic. Stay tuned. Tomorrow begins right now. There you go. Like that one? All right. There we go. Mike, we're done with you.
All right, good
Thank
show,
you.
guys.
We'll see you in 2 weeks, Mike.
All right.
Boom, we're done with him. And bars. And Dimitri.
So close.
Aw.
So close.
I have like weird interference on my belt pack too.
I can't believe that you couldn't remember what section we were in. You're like, no, I always dance to that song. And I'm like, you always dance to the boop, 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 boop.
Hi, Dimitri.
Boop, boop, boop.
Hey guys.
Yeah, that show fell apart really fast.
Good job.
All right, so there were some
I was
questions.
like, I'll just ignore it. I'll ignore it. And then he'll just catch on and it'll be fine and we'll move on and nothing will come of this. And you're like, no, Donna, back me up on this one. I totally always do it.
Thanks. All right.
I was trying to help you.
I'm going back to some questions. Yeah, I know I failed miserably.
Yes!
Segment 3 is a
Exploding
miserable
kittens.
failure. I'm so sorry. All right.
All your fault.
Let's see here. Minnesota. Sorry, I'm going back to find some of the questions that we glossed over.
Yeah, what happened to our question room? That's what I was trying to find when you were yelling at
You
me.
go here, and then you're not in it.
Awesome. Well, aren't you?
Maybe.
Well, all of them should have been in there. Should they not have?
Oh, yeah, look at that.
Yeah.
Okay, here we go. All right.
Stooge. That's why we have that thing.
All right, Tars. So mini Elon, how much mass? You covered that.
I gotta say, wait, really quickly, Dimitri, you were such an amazing interview. We hardly had to ask you anything.
That was great. I love that. I'm like, tell me a thing, and you went.
It was great, but it was hilarious because we were like, all these questions are coming in, and Ben's like, you take this question, and then you would answer the question, and I was like, oh, okay, and then Ben would go, you take this next question. I'm like, yeah, no, that's a good question, and then you would answer the question without us asking, and so anytime. So it almost got
great. It was great.
It was our own personal drinking game of like how many questions can pop up in the chat room, and Dimitri just answers before we even ask them.
You forgot to mention the Twitter the person's name when you asked your questions.
Because it started with Strepstick, and I always mispronounce Strepstick's name, and I didn't want to be like, so says something in the chat room, and so I was like, I'll skip over that, and then everything else. So I apologize, Strepstick, to Wicked. I think to Wicked, I asked 2 of your questions. Strepstick, I again with mispronouncing your name. I know I did that wrong. All of those things. I did lots of wrong things. You screwed up the 3rd segment. We're even.
All right, so let's go back. Darichi, not sure how to say that, said, how much how much do you project a launch will cost? I think that's more than just the kilogram to orbit or you know what I'm saying. But how much is a full-on launch?
Right. That's an interesting question. It will basically be determined closer to the time when we actually start flying payloads. Our target on a per kilogram basis at high flight rates is at $150 per kilogram. And so if you think about this, if we're launching hundreds of kilograms, it basically amounts to substantially below $1 million per flight. And how quickly we can get there, that's a different question. We will probably, the goal is certainly to start below $1 million per flight, and that's for the first few flights, and drop it down as quickly as we humanly can to hundreds of thousands per flight.
But and, even if you can't, even at millions, that's still the lowest cost launch provider, like, on the planet.
By far, but you need to keep in mind that this is not a non-reusable vehicle. We do not throw away the vehicle. That's what eventually will allow us to reach those low costs. Yeah, and if you think about the prices per kilogram for both chemical rockets and for external propulsion system, the cost of expandables in a kilogram. So imagine you've got a kilogram of payload and you need to launch expendable count the cost of expendables. For chemical rockets, it's about $30 per kilogram, and for our system, it's about $40 per kilogram. Electricity plus hydrogen. But if you add to this 60 million of the rocket cost, that basically kills the idea. But if you stop throwing away the vehicle, that's what makes this big difference. That's what allows, and everything on top of this, in our case, there will be, let's say, several $100s per kilogram on top of the just expandable. This comes from the amortization cost of the infrastructure. We're not building non-reusable rockets, but we are building infrastructure on the ground that will need to be amortized over, let's say, 30 year period. The cost of this infrastructure will need to be amortized, and so that what will add some amount to the cost of expandables and the cost of operations, etc. But yes, we do believe that it is realistic to think that, say, 10 years from now, we will be flying at a price point of several $100s per kilogram. That's a game changer. That's when most people can afford to fly into orbit, not just suborbital, fly into orbit.
Yeah.
Yeah, it'll open up a ton of research from university. It'll just open up a ton of stuff. It'll open up an entire new industry.
It's somewhere in here. I don't remember where it is, but somebody asked about can this technology be used for basically garbage disposal in space? We have a lot of dead satellites up there. Can you go up and take something back down?
Well, you could. I mean, it depends on the modality, right? So if your goal is just to fly the vehicle and try to chase a debris or a satellite and capture it and fly it back, yeah, I mean, if the customer is willing to pay for this, it is possible. I'm not sure that it's the optimal way, and I'm not exactly sure that there is a huge demand for this. Frankly, I think as we evolve as the society, launching stuff into space, we will just introduce more and more systems for those satellites to get self-removed, just to get deorbited and burn in the atmosphere. But in principle, why not? If the customer wants us to retrieve a satellite instead of just blowing it up into pieces, yes, it should be possible.
This is an interesting question, which will spiral into two. This is from Sir Kardashev. Sure, we'll say that's how you pronounce that. It says, how many watts reach the ship, and why don't the astronauts saute from them? That's, of course, making the assumption that this is a human-capable ship, which my understanding is not. This is a cargo only. Yeah. So I'm going to break it into two then. I'm going to say how much power is actually making it to the ship, say, off of 100 megawatts, how much makes it there? And then the second question is, can you put humans on it?
I apologize.
Okay.
I'll step out for just a second.
Yes. So the first, to answer the first part of this question, we are planning to build a non-human, it's a payload concept. We want to deploy payloads into orbit, at least initially. After several thousand flights, and when the amount of payload we're putting grows to, say, 1 ton, 1,000 kilograms, the concept may become human rated. The way to do this is basically microwaves do not propagate through Faraday cages. If you've got a metallic enclosure inside of your vehicle, microwaves will not go inside. That's just the basic physics. So it is actually pretty simple to shield everything, and we will need to shield electronics anyway. It is possible, and people do this all the time, shielding electronics from EMI, from electromagnetic radiation. It's been done, and it's pretty well understood how to do that. Now the second part, but initially this concept is certainly targeting payloads and small satellite deployment, and for the first several years, for the first several thousand flights, it will be fully unmanned and fully autonomous concept. Now in terms of efficiency, our link budget from the antennas to from the electric grid, I would say, to the launch vehicle is ranging from about 35%, 40% when we are at the launch pad, to about 10% when we are in the worst parts of the trajectory. So the amount of the fraction of microwave energy that reaches the vehicle ranges from about 10% to about 45%. And the important part is that electricity on the ground is cheap. It's not a big cost component. So even if we are only 10% efficient, the amount of dollars we are adding to the cost of the per kilogram launch is actually negligible. And so this efficiency matters less. What matters a lot is the efficiency of the actual thruster, the efficiency of the engine, and that's what needs to be really high. So yeah, I think the 10 to 35% efficiency across the entire trajectory is the answer.
Dada, can you bring the vehicle image back up? Because if I remember right, at the back end of that, there's a little note that says, hey, here's the aerospike engine, and we didn't really talk about it being an aerospike engine. Are you doing that just so that you don't have to deal with efficiencies of a nozzle, or what's the point of that?
So historically, air spikes or compensated nozzles, they've been known to be good for certain applications because basically we're not losing, we're gaining about 10% of efficiency compared to a bell nozzle by using air spike. But and so for SSTO, for single stage to orbit, it's actually becoming even more important because we cannot, it's harder to optimize a stage. It's easier when you are staging rockets, you can have one nozzle on the first stage and a different nozzle on the second stage. In this case, it's an SSTO vehicle, so our nozzle better be optimal across the entire trajectory. And there is another very interesting fact. When we deal with combustion-based systems, when there are chemical combustion processes before entering the nozzle, there is combustion instability that actually makes air spike nozzles slightly less efficient. In our case, we're dealing with a monopropellant heated hydrogen, and so it's easier to control the flow and fully utilize the efficiency of the air spike nozzle compared to what would happen with the chemical combustion rocket. So one, it's a SSTO. That's therefore it's really beneficial to use air spikes. And secondly, it's pretty unique to external propulsion because it's just hydrogen. We can utilize more of the efficiency gains from the air spike nozzle.
Wicked had a question. He said, all of the systems are in very early stages. For example, wireless power hasn't gone past relatively short distances pointed at stationary targets. Oh, by the way, Dada, you can clear the image. Do you have any timeline expectations for these systems to become useful? A decade, 5 decades, 10 decades?
Well, our goal is to be orbital in the early 2020s. So right now we are beaming power in the lab, and we're beaming across the hangar size distances. the next step is to take this concept to the outside, and frankly, there is very little preventing us from doing this right now, and that will be tens and hundreds of meter distances of power beaming. It is clearly possible from the technology standpoint to bring this concept much sooner than several decades. And actually, an interesting fact is after NASA has seen the progress of the external propulsion community, the work of NASA Ames, Dr. Kevin Parking at NASA Ames, and our work, after they've seen the progress, seen that we've demonstrated things and there is working functional hardware, they changed this concept on their technology roadmap from something that could be done in 2035 to something that could be an alternative for affordable space access in 2020 timeframe. And it's actually happened just a few weeks ago when the NASA updated their technology roadmap and introduced this as the promising way of lowering the cost of space access and introducing new propulsion alternative to chemical combustion was a big, I think it was a very big win to our concept and what we are doing, and other companies or organizations interested in external propulsion are doing. So I would say it's a 2020 timeframe. It's not a few decades from now.
And I wonder if the comment actually makes an assumption that's not true. It says that short distances pointed at stationary targets, but you, excuse me, you have video of it powering the drones that are moving, right? And you're tracking.
Yeah, we're beaming power. We're doing the low energy power uplink. We're not yet powering the vehicle with our energy, but we're doing low energy uplink just to show that we can do it very efficiently. However, the comment is slightly misleading because yes, people did beam power and use that power to power flying vehicles with microwaves. William C. Brown from Raytheon did the experiment where he powered a helicopter with S-band microwaves way back in 1960s, and Japanese team recently did a long distance kilometers power beaming several kilowatts of power. We're beaming more than that, we're beaming tens of kilowatts to the thruster. Here in this test, we're beaming only, it's not powering the vehicle, it's only doing the uplink so that we can demonstrate that we can have efficient energy uplink. But we are beaming tens of kilowatts to an engine, to a functional engine inside of the enclosure. So both us and the state of the art is beyond small amounts of power to stationary target. The state of the art is beyond that.
So why not power the vehicle? I mean, if you've got the link, could you?
Right now?
You? Yeah.
Oh, we certainly could. The challenge that we are facing and our next step is to take it outside of the lab. One of the things we do not beam tens of kilowatts in the lab in the open, and this is safety. So we do not use hydrogen in the lab, and we do not use open beam in the lab because of the safety concerns. So our next step, we're right now in discussions with the test range where we can take the entire system outside, and we're also applying for FCC licenses so that we can do this reliably and safely and demonstrate to the world that this is not only doable, but it's doable within the constraints that we've got from FCC and FAA. So it is certainly possible. We're working towards this, but right now we're limited by the fact that we are operating out of an enclosed lab.
Dutta asked, who's our director, back behind us. He said, with those two arrays, because you're talking about beaming with two arrays, can you only hit certain orbital inclinations then at that point?
No, it's actually, there is one optimal inclination, but other inclinations can also be reached. And by optimal, I mean energy-wise. If we want to rotate the vehicle and impart more delta V in the direction transverse to the plane, so there is, when we've got two arrays, there is a plane where it's optimal to launch. If we're only launching in this plane, that's just the easiest one. But the beam is a conical beam, so it can basically cover a cone around the array, and so we could do the rotation while inside of the beam. It would just add, let's say, kilometer or 2 kilometers a second delta V that you need to impart. So it basically would either require more propellant or require pretty much it will require more propellant at this stage.
Towicked asked, with rapid reusability, what's the life expectancy of a single vehicle heat shield?
Yes, that's this is the question of the day. So the short answer is we are testing this right now. We expect it to be tens of reuses for the heat shield. And then we want to manufacture those heat exchangers to be swappable, obviously, so that after, let's say, after 20, 30, 50 launches, if it finally degrades beyond the level of usability, we will just swap it instead of trying to retrofit it or maintain it. It's a plug and play, like you swap a battery in a car. And but the goal is to make those heat exchangers and the heat shields on the vehicle to be reusable for tens of times, and then reduce the cost of producing a single heat exchanger to somewhere where it does not impact substantially the cost of the space plane.
Citizen 59491, you can log in, Citizen, asked if elements of the microwave array are off target, is there enough energy in that microwave beam to damage a satellite in a higher orbit?
So basically, it depends on what orbit it is. It certainly could be if we didn't do it within the proper constraints of the way people regulate launches. It's like with the chemical rocket. If you launch it into the trajectory that intersects a satellite, yeah, it will blow up the satellite. So that's why, and the same is with airplanes. We don't fly airplanes over Vandenberg when we're launching when the Falcon 9 rockets are launched, because you do not want those things to intersect. And the same is true with the external propulsion launch. We've got a window of 300 seconds, approximately 300 seconds of launch. The beam is tracking the vehicle, so the beam is only falling on the vehicle as the vehicle flies. Now, there is a chance that though something is off nominal and the beam misses the vehicle. We've got a few milliseconds to turn the beam off, which we can't do. I mean, in our lab right now, where we've got the interlock procedure that turns off the beam within milliseconds of anything off nominal. Let's say whatever, the door opens, the beam is terminated. And the same is true for the space launch. We can terminate the beam pretty quickly during the off nominal operation, but as with any launch, we will need to coordinate with FAA, so there are no airplanes in the field. We will need to coordinate with all the players who might have satellites in the nearby orbits, so that we know that those satellites are not impacted. And finally, I mean, the beam, after the focal point, after where the beam converges on the vehicle, it starts diverging pretty rapidly, and so the power density decreases. It certainly will not impact any satellite at 1100 kilometer, or certainly not in the geo. In the geo, you wouldn't even notice that. Yeah, if you are in LEO, if your bird is in LEO and it gets straight into the beam, yeah, you probably will get some form of an impact if you've got microwave sensitive electronics, which is often not the case. Surprisingly, microwave beam do not actually impact so much electronics that we operate every day, like cell phones and cameras. We've got cameras in the enclosure that measure that basically capture the experiments. And initially we did shield all of them, and they are all shielded. But once we just left the camera there, it functions perfectly well. So it's not all that damaging if you don't put something straight into the beam.
I'll say the same is not true of radiation. That will rip through a camera's sensor something fierce.
Yes. Yeah. Well, microwaves are very different from penetrating radiation. Microwaves are not penetrating radiation. Yeah, it's a big difference.
U5KO asked, why not pitch this for off-world applications at an early stage? Seems like it'd be a nice fit for lunar launch.
It certainly would. The challenge again is the business side of things. this system to work, there needs to be paying customers and need to be substantial interest. There is a huge market demand in launching small payloads today in the world, and generally in getting into LEO. The you know, the cost of building those things is expensive. Building microwave sources, antennas, it's an expensive proposition. There needs to be a business case, and so we're basically trying to find the most realistic and fast to market business case as possible. I think in the future, after we develop those systems, yeah, there will be a lot of off-world application on the moon, on Mars, possibly. Yeah, that will be exciting. But this is the second step.
Wicked was interested, had a lot of questions. If you only need to heat the hydrogen, why not go with lasers? Why not go with lasers instead of microwaves?
Right. So lasers are certainly possible, and they've been proposed there's basically this debate of some form in the external propulsion community whether to use lasers or to use microwaves in the space launch applications. There is one big substantial difference. Today, high power lasers per watt costs 10 to 100 times more than than the current microwave technology, and we believe that with our innovation, with the developments we've got here at Escape, we can bring the cost of microwaves actually substantially below what's possible today. So it's basically the cost per watt. We believe that we can substantially lower the cost of ground-based infrastructure by choosing microwaves. And another thing is the phased array combining, beam combining is not, it's visible. We know that we can do it. And it's not harder than combining actually multiple thousands of lasers. We would need to combine much more lasers than we need to combine microwave sources, because the typical output of a high power laser is in tens of kilowatts regime, and a typical output of a high power microwave source per unit is in hundreds of kilowatt regime. So there's an economy of there is some economic forces that basically drove our decision.
Mini Elon had asked if the heat of reentry has any possibility of reigniting that liquid hydrogen and basically turning your engine back on.
So we do not ignite hydrogen in general, but we can use the heat of reentry, recapture this heat of reentry, and start pumping more hydrogen through the heat exchanger to cool the heat exchanger first, and secondly to slightly increase our maneuverability as we are gliding back to the launch site. Yes, so it is possible to recapture, reharvest the heat of reentry to add a little bit more of thrust and a little bit more control during the reentry. Whether it will be needed or not, that's a different question, because it's obviously adds complexity. But it is possible to reuse the heat of reentry and to restart the thruster.
So you guys are based in Colorado, correct?
That's correct.
That means that everything you do is based on covered under ITAR.
Well, yes,
okay.
Obviously.
That was just a question Badger Legs asked. You're just wondering if everything you do is that going to be an inhibiting factor for trying to get foreign companies to fly payload or anything like that?
I mean, SpaceX is flying foreign satellites regularly, so I'm not sure that no. So the short answer is ITAR will probably not restrict us from launching payloads. In some cases, if it's North Korea or something, it may. But in general, typically economics is less impacted from the ITAR. What ITAR is impacting us as any company, SpaceX or ULA, any company, is what information we can share or not share publicly, and what information we can and cannot share with companies outside of the United States. So we, for example, would need to get special permits, technical assistance agreements if we wanted to co-develop a technology with a foreign country. And we are not sharing publicly any videos that contain technical data. But other than that, from the customer's standpoint, no, there is not much impact on the business side of things.
So Badger Legs asked, and this is going back to orbital debris, is can you use your microwave beam to directly propel satellites out of orbit? And I think, everyone's saying satellites out of orbit. We have satellites solved. I think there's a misunderstanding of what orbital debris really is, which is mostly leftover rocket parts and other things that have already exploded and have no propulsion built into them. But a satellite already has propulsion. If they're done with it, they can deorbit the satellite and they're done. That's an easy process they have today. But let's say we had something else. There was a collision event that happened in space. You've got a bunch of debris. You want to get that debris out of a certain field. Can you hit the debris with your microwave and move it at all?
So in theory, the answer is yes. Whether it is the most optimal way of dealing with space debris, probably not. I think the good thing about microwaves is they actually disperse quite rapidly. The power density decreases outside of the focal point, outside of the maximum. So even on our vehicle, we're focusing energy into 10 square meters, not into a small spot. So I would say if from the space debris mitigation standpoint, lasers could potentially be more efficient than microwaves, but microwaves could be used. The question is whether it could be done economically or not, and is there a business case for this? Well, it can be done. We are certainly not targeting this as our near-term market, but we will be happy to explore those concepts if there is interest.
Our director, Dutta, had another question, which is, does the power transmission interfere in any way with the communication to the vehicle, assuming that you're going to have to communicate with the vehicle, right? You're going to have to provide some sort of something.
The microwaves we are using for power transfer are very much removed in the frequency domain from where the comm is happening. The power beaming is done in millimeter waves, so our first gyrotron is at 92.3 gigahertz, and all of the comm is happening at much lower frequencies, so below 40 gigahertz, and that's why, frankly, there is very little potential for interference, and there are very reliable and industry accepted workarounds of how to deal with that interference to make sure that it doesn't happen.
Karen Radcliffe asks, when can we expect a ground test of the full-sized rocket?
Our technical team is targeting for the full-sized vehicle in 2018-2019. The ground tests, and for the engine, it's before that. But that's as in any hardware business, this is not something I would sign under. I mean, we're developing hardware. It's really hard. We are not focused on right now on the tests of the ground vehicle or on the flight test. What we are focused on is step-by-step execution. Our next goal is to take the system out of the lab, do the tens and hundreds of meters of power beaming and power efficient 750-second ISP thruster. This is the next milestone that we're targeting for next year, and for early next year, and that's what we are focused on. It's in this business, it's better, I think, to really focus and execute very well on the next step and do things right. I would not commit to the time when we actually plan on doing the ground test. Our next step is what we are trying to execute efficiently on.
Space Citizen asks, how's the company financed? Where are your profits coming from at this stage?
So we are a pre-profit company. We're financed privately, and the primary investor is one of the co-founders of the team. Richard Shaden invested most of the capital into the company. So Richard is a entrepreneur who's built a substantial fortune in his other business endeavors. Well, right now our focus is not on making the profit, but rather on building the technology that eventually will allow us to make substantial profits and positively impact humanity at the same time. So, but basically right now we are pre-profit.
Oh, you're lucky, because that's a longer-term vision, right? You look at normal venture capitalists or anything else, they're looking for a very fast turnaround, but your stuff is going to take a little bit longer to develop. The upside is very, very huge, but
Yes.
you're going to have to wait for that upside.
Right, and that's why it's so important to find visionary strategic investors and partners. With Richard, it's been a huge blessing. When I met Richard, this vision is possible because of his vision, because he didn't look for immediate profit. He realized, yes, this is a legacy. This is something, if we or when we are successful with this, the world will be a better place. It will be a different place. We will be able to do things that are completely impossible today. And so he invested on the basis of this vision, less so on the basis of the immediate ROI. And when we are talking right now to our strategic partners to build a system with us, we are looking for visionary companies who want to build the future of airspace, who want the world to be better. And so as we grow and are looking for strategic investors, strategic partners, that's what we are looking for.
Congo Blast asked, will clouds be a problem?
So basically, the attenuation of the microwaves goes in proportion with the amount of moisture in the atmosphere. The more moisture there is, the more attenuation we experience through the atmospheric column, the more energy we basically lose. So the goal is to launch from a high altitude location in a dry climate, like a desert in New Mexico, or there's plenty of locations like this with very low humidity and very infrequent cloud cover. It's also good because since we're beaming microwaves, we want to be fairly removed from the big population centers. So
Not
clouds,
Los Angeles?
probably not immediately in Los Angeles, yes. But clouds do attenuate, and so we'll need to launch on days with low humidity. Not necessarily low clouds, but certainly low humidity in the atmosphere.
Dutta, do you want to... So you have your question, which is long and complicated, but it's fairly simple. Do you want to just ask it yourself?
Sure. I think I missed something. On board the craft, you have liquid hydrogen. Is that correct?
That's correct.
And so then you superheat that via microwaves with your heat exchanger?
Yeah, if you bring back up the picture of the vehicle,
Give me just
there
a
is.
second. Boom.
So there's a hydrogen tank. There is a turbo pump that sits near the nozzle. And so what the turbo pump does, it takes the hydrogen and it pushes it towards the nose of the vehicle, and it makes one loop in the ceramic matrix composite heat exchanger. So the hydrogen is taken from the tank, pushed through the heat exchanger where it heats up, and then it's expelled through the air spike nozzle.
Okay, so you're actually consuming hydrogen to get into orbit.
Yeah, so
Okay.
I mean, we are expelling hydrogen. That's a reaction mass. There is no magic behind rocket propulsion. You need to conserve the momentum. You need the reaction mass.
Which you're not setting it on fire.
In this case, yes, there is no combustion.
Right.
What makes it efficient is the fact that the hydrogen is expelled from the nozzle with a very high exhaust velocity.
Gotcha.
So the higher your exhaust velocity, the more efficient your propulsion system is. Thrust is the product of the exhausted mass and the exhaust velocity. And so you can either expel more mass or you can increase the velocity of exhaust. And heating hydrogen with microwaves basically allows for the highest exhaust velocity of any thermal propellant. And that's what basically drives the high specific impulse of the system.
I gotcha.
Does that add safety as well then? Because you've got, a traditional rocket, you've got a combustion event going on. That's why we're bringing liquid
Right.
oxygen with us, because you need the oxygen when you leave the atmosphere. Right. You don't have oxygen, liquid hydrogen, combine the two, combust, big controlled fire. You don't do that though.
There is no controlled explosion in this vehicle. Yeah, that's completely correct. And so safety-wise, the system will be advantageous compared to chemical rockets. Yes, there is nothing to explode. unless there is some major rupture of the tank when we are in the atmosphere, which we obviously will work really hard to fully prevent or to mitigate. But the interesting thing about this, about what we're doing, the vehicles we're building are small. 200 kilogram satellite can be deployed with the vehicle with the total mass, wet mass, with the propellant of around 3,000 to 3,500 kilogram. And so if you think about even if things go woefully wrong and there is an explosion, the explosion of a vehicle of this size compared to the explosion of a multi-kiloton vehicle is very different. It's a very different story. It will be like a bump, and it will not even blow up the launch pad if things go horribly wrong. There are substantial safety benefits. From not carrying explosives, not carrying oxygen hydrogen mixture. Second is the vehicle itself is safer because it's simpler. The engine is simpler. It's thermal thruster. There is less moving part. There are less things to go wrong. And third, it's a smaller vehicle. Yeah, there are.
But you still have one of the most complex parts of the rocket is of any chemical rocket's the turbo pump. That thing's nasty. And you still need a turbo pump here, though.
Yes, and it's been brought up as the complexity, as an additional complexity of the propulsion system. But if you think about it, and we talked with several people who've been in the industry and building turbopumps and flying real turbopumps on big rockets for decades. I would say that the complexity is somewhat overrated. I mean, it's probably not a really humble statement, but it is doable. I mean, turbopumps are doable, and the more we build of them, the more reliable they become. It's not. It is unfortunately an added level of complexity to the whole picture, but. If we count the complexity that we remove and only leave the complexity of the turbopump, yeah, it's still beneficial. It still wins by a lot. So I would say that the dealing with the turbopump is on par in complexity with dealing with the heat exchanger, which is another major complex component. It's sort of simple in principle. We've got a silicon carbide tubes that flow hydrogen through them. But it's much more complex than just this. The geometry, the topology, the actual fabrication and integration of those things, it's slightly more complex than actually building a turbopump because they've never been built before.
You know, the other complex thing you have is actually just the fact that you're using liquid hydrogen. You go back to the space shuttle or any vehicle that has liquid hydrogen. That stuff's hard to contain, and it's cryogenic.
It is.
Do you have any other
alternatives?
Anything you can use that's easier, or do you just the loss is so high that it doesn't make sense?
So the highest ISP of a thermal thruster above 750 is achieved with hydrogen. If we used helium, we would be in the 500 second.
Well, helium's not easy either.
But helium doesn't give us much advantage, right? Because it requires substantially harder cryogenic. It goes liquid at 4 Kelvin instead of 20 Kelvin for hydrogen, so it's no big benefit. The only benefit of helium, it's not explosive, so it's a little bit easier to handle. Now, in the future, there is a potentially very attractive alternative to this, and this is to move away from the thermal thruster, use microwaves in a different modality, use microwaves to basically heat plasmas on the vehicle, to ionize the propellant and expel the ionized propellant. This would allow using, for example, CH4 or argon. The trade-off here is we're shifting complexity from the propellant tank, which is a component that we at least understand, to the complexity of a plasma thruster, which has totally never been built. Well, we know that we can heat a piece of silicon carbide and heat hydrogen flowing through this piece of silicon carbide. Now, if we shift immediately to ionizing the plasma, expelling plasma, building the magnetic nozzles, and packaging it into a flying vehicle as our first product, the level of complexity goes up 10 times. So hydrogen tanks at the level of complexity, let's call it 2, plasma thruster would add the level of complexity of 10. And so it's prudent to start with something that we know we can launch and then innovate from there. But yeah, hydrogen and turbopumps, that's a challenge, but it's the same challenge as rocket companies are solving today. So it's something that people have experienced engineering around.
A couple questions related to crew on board, although I do want to clarify for the chat room again that this isn't a non-human rated vehicle. This is for they're working on cargo.
Yeah.
Crew maybe someday in the future, but
Long
cargo. So
Yes.
With that, I'm going to read you the questions as they're written in the chat room with the understanding that this is a cargo vehicle. What about certification? Once a person's on board, the legislation in this case is very restrictive.
No kidding.
Yeah, so I don't think there's an answer there because it's not
This is
not a
true.
crew vehicle.
Yeah, no, this is true. Yeah, it will take a long time before we can even think about putting humans on board.
Second one's from the gaming scientist. Since there's no combustion, will it be safer than other space planes? Also, what are the abort mechanisms to save the crew from a rapid unplanned disassembly?
Yeah, so absolutely, certainly true on the safety. We do because there is no combustion. As I explained earlier, we do believe that it is a much safer concept. The spaceplane is safer, propulsion system is safer. The size of the vehicle, the small size of the vehicle, adds to this inherent safety of the concept. Now, what is a board scenario for the crew is just too early to discuss, but let me give you a slightly different side of this question. What if we've got an off-nominal, let's say a bird flies next to the beam and we shut down the beam before the bird enters that beam? The vehicle is a lifting body vehicle. It's designed to fly into space and re-enter and come back. So in most abort scenarios, we can have the vehicle as a glider land at an airport street, or basically glide back to the ground and in the control, if it's over ocean, in a controlled way, just be dumped into the ocean. But because we've got an airframe, in theory, practical applications can actually allow much more abort scenarios than would be possible in a chemical combustion rocket.
All right, two more. Also, you have to land it in the LA River at some time, just because the Hollywood cinematic world requires it. Two more questions, and we're going to call it a day. The first one comes from Meyer, who asks, "What runs the turbopump?"
Yeah, so that's a great question, and we basically the way we control the vehicle is by controlling the operation of the turbopump, and there is a mechanism that we invented and are working on that allows us to use hydrogen from the heat exchanger to power the turbopump and to control the turbopump as well. It's somewhat proprietary, so at some point when the patents are published, there will be more information online on how we are doing that. But basically, the same hydrogen that we're using and the same microwave energy that we're using to power the actual thrust, to create the actual thrust, is used to power the turbopump of the vehicle.
And the final question goes to Tawicked. He was on fire today. He asked a lot of really great questions, so good job, Tawicked. Do you expect any issues with the beaming farms? Specifically, the loud and uneducated public may not like massive microwave emitters near them.
So, certainly there is a level of complexity brought in by the fact that we have the energy transfer from the ground. I think, frankly, we are doing this step by step. We're doing it gradually. We're working, we're talking to all of the people who may be impacted. We want to step by step show that it can be done completely safely. We can guarantee that there will be no off-nominal, and if there is off-nominal operation, the beam shuts down. We're not beaming hundreds of megawatts right now. We're starting with kilowatts, and we will be step by step demonstrating that it is safe. And people need to realize that, yeah, there are things in the world that are dangerous, and if you don't handle them properly, they may be dangerous. Rockets are, microwave beams are. That's why we want to run very conservative safety campaign and do it step by step, gradually, working with all of the stakeholders to show, and not only to show that it's safe, but also to create all of the necessary operating parameters. We can ensure that energy is only present at the vehicle, and there is no impact on the communities around. There is no impact on wildlife, and it is possible. So it is not the question of I think whether it's possible to do it safely. The question is how do we show this to the world that it is safe? It's like any other technology. It needs to be gradually introduced step by step, and that's our plan. We want to show to the world that we know how to do it safely, we can do it safely, and that on this other side of us doing this safely is the huge boon to humanity. We can launch things in a very novel and different, better way. So that's my answer, I think, to that question.
That's a good answer. All right, Dimitri, thank you so much for taking time out of your Saturday. I think what you're doing is awesome. I'm really excited to see what you guys are actually able to accomplish, and it's really great to see you guys with real test hardware, actual things working, more so than just ideas on paper, but hardware being built and doing things to help push humanity out to the stars in one way or another. I think it's really, really awesome what you're doing.
Awesome. Thank you guys for having me.
Thank you.
Appreciate
All right.
it.
Have a great weekend. All right. And for everyone else watching live, that is our show this week. I hope you enjoyed After Dark. Thank you so much for joining us. And like I said, we're going to the D23 Expo to get our Disnerd on, because that's what we do. Since you said, I think, 8 words this show, did you want to, anything else you wanted to say?
To Wicked.
Great. So thank you. I'm just kidding. I'm just kidding. What do you want to say? I do that to her in real life, too. This didn't work at all. Anyhow, yeah, To Wicked what?
Said, damn it, came here fully expecting this utopic dream, but he kind of sold me on the tech.
No, seriously. It's a reasonable idea. And they're doing stuff. And they're making things happen. And they have investors who understand that this is a long-term... This is like a dream team of people. I'm really excited to see where they go with this. I'm very glad that he was willing to come on the show on a Saturday and talk to us for so long. He knows his stuff. I told you before the show, I said he's going to be changing the world. I said those words, and I even after the interview, I believe it more so now than then. So that was cheesy, but true. So there you go. Hey, everyone, thanks for watching. Thanks for working in the new chat room. So I know there were some issues. So there's a Reddit there's a Reddit thread right now. If you go to reddit.com/r/TMRO, where you can talk about certain things. I know Dada mentioned that when you log in, you can't enter to continue. There were some other weird issues that we kind of noticed. So Colton is looking for that feedback, looking to make the best darn chat client on the face of the planet, so that as you guys are joining our live shows, this live chat experience is kind of seamless and integral, and it just works really well. It still works with IRC, obviously, so if you use your own IRC client, you can continue to do that, but yeah.
And Space Mike is thinking about doing some tomorrow space podians. What am I trying to say?
I haven't the slightest idea.
Space Mike is thinking about doing a show next week, essentially.
Oh, a little Space Mike hosted show.
Yeah, so he's got some stuff going on going on Reddit for ideas for ideas for the show. Any sort of topics you guys want to cover, anything along those lines.
I like that idea quite a bit. All right. Hey, Dada. Yeah. Are you going to D23?
I don't have tickets.
Hey, Space Mike, call us back. Hey, Dada, would you be mad if I made you do a show next week?
If you made me do a show next week, probably not.
You're still going to pay him, right?
Oh, yeah.
All right.
It looks like a regular show.
Just figured I should,
Thanks for covering my back on that one.
No problem. I just didn't want him to forget.
I mean, I'll pay him the same $0 I pay him now.
Well, I just want to make sure that the $0 still go
Yeah.
to Detta because, you know, he's got a family to support now.
Wife and starving child.
Starting child.
Star-
you have a starter
starving.
child?
Starving.
Is that like a starter home?
Yeah.
Skype wanted to connect and then it didn't. That's all right. So I was thinking if Space Mike wanted to do a show and wanted to use the control, like have access to this, we could bring him in via Skype and still use like the Casper system and the whole thing. So it could be like a regular live show.
It'd be an empty room.
Oh my God, that'd be hilarious. Like, oh my God, yeah. So it'd just be him on the screen. Him on the screen, but like the chairs are empty.
Yeah.
That would be awesome. But no, I meant, you know, we've already got the CG roll system. We've got the script
Detta
system.
and Mike in the morning.
So even though he's coming in via Skype, you can still do some
No,
cool
I understand.
things.
I understand.
Well, anyhow, we can figure that out offline. On that note, thanks everyone. Have a great week. See you in 2 weeks.